Next is the primary high-speed circuit. The construction of this is similar to that in the carburetor model we looked at earlier. It is the most widely used main circuit, although there are mechanisms to activate to assist when extra or speed is needed. This side is the primary barrel on this model. The Venturi is designed this way for maximum mixing of air and fuel. The primary high-speed circuit works as follows. When the throttle valve is opened wide, allowing for a higher speed and volume of air to Venturi, the amount of fuel that is delivered is equivalent to the intake air volume drawn into the barrel. The amount of fuel is controlled at the main jet before it is mixed with the primary air bleeder and injected from the main nozzle. The fuel is atomized by the air flowing at high speed past the Venturi, from which it enters the combustion. This is how the air-fuel mixture is regulated during idling at low and medium speeds. However, this alone will not produce the power needed during high-speed operation. This is why the double-barrel carburetor has a secondary barrel. The construction of the secondary barrel is the same as that of the primary barrel. It has a high-speed circuit, which is its main circuit, and a low-speed circuit which prevents the mixture from becoming too lean when the throttle valve opening on the secondary side is small. Let's look at the secondary low-speed circuit for the secondary barrel. If the primary throttle valve opens more than 60 degrees, the cam in the kick-up system will force the secondary throttle valve to open slightly, and is then secondary slow port, causing fuel to be delivered to the intake manifold. When this happens, the vacuum bleeder, which is part of the Venturi, produces a vacuum which opens the secondary throttle valve. When the engine RPM rises, the pressure from the vacuum bleeder overcomes the diaphragm spring, which in turn causes the secondary throttle to slowly open. The secondary low-speed circuit, like the primary low-speed circuit, uses a solenoid, so that when the ignition switch is off, the root is closed off. Now let's move on to the secondary high-speed circuit. When the secondary throttle valve starts to open, a vacuum is created by the vacuum bleeder. This is strengthened by the diaphragm, which causes the second throttle valve to open further. The fuel is injected from the secondary main nozzle. In this way, both the primary and secondary barrels work together to produce the air-fuel mixture necessary for high power.